Hi there, Turgeon here, bringing you Physics from Afar. Here are the answers, and more importantly, the solutions and the reasoning behind the specific heat practice. Write extra. Go beyond just the words that I say and listen for those moments when I tell you to write a little extra to prove that you really listened to the video. Specific heat is the heat. I want you to remember that. Specific heat is heat. You can draw these lines coming out of the word heat to sort of represent a flow of something, a flow of thermal energy. It's the heat to change the temperature. Be careful, don't say it's the amount of energy needed to heat something up, because saying that we're heating something up is not very specific. So it's the heat to change the temperature by 1 degree Celsius, but you got to make sure you say that it's 1 kilogram, because you don't want to compare 1 kilogram to 10 kilograms. Inertia is resistance to a change in velocity. Put the word velocity here so I know you really listened. Specific heat is resistance to a change in temperature. That word is temperature. That's key. Now I'll explain all these answers to number 3. You want to say joules. Now I know on the table it says joules per kilogram degree Celsius, but this says how much heat is needed. Since it says how much heat is needed, it's asking you to relate this to the flow of thermal energy, which is the heat. So yeah, that's what that number means. And now you think if it's 2 degrees Celsius, it's going to require more heat. If it's 3 degrees Celsius, it's going to require more heat, 12,558. And you keep that logic going. Silver has a different specific heat. Alpha alcohol, why 12,000? Well, this is reasoning. It says don't use equations. 500 grams is half of a kilogram, so that's going to be half. If you look at the specific heat of ethyl alcohol, it's 2,400 joules per kilogram degree Celsius. So if it's only half a kilogram, that's 1,200, but then it's 10 degrees Celsius, so multiply by 12. I know I said that fast, but it's a video. 10 degrees Celsius is 10 times the amount of heat for water. In this one, we're asked to go from least to greatest. The least temperature change is going to be the thing that resists the temperature change the most. Write that right here. Write that on this line. Where is the resistance? What resists the heat, the temperature change the most? What resists the temperature change the most is the water, because it has such a high specific heat. Number 4 is really about specific heat. They're all 7 kilograms. It's not about the mass. They all had the same amount of heat flow. It's not about the heat. It's about the specific heat. It's about the substance, and water resists the most. So it has the least temperature change. Lead resists the least. Its specific heat is only 130 compared to the 4,000 something for water. So that changes temperature the most. Number 5 is also about resistance to temperature change, but it's based on mass. They're all iron. So the thing with the most mass is the thing that's going to resist the temperature change the most. So the most mass is 300 kilograms, so that will have the least temperature change. 50 kilograms has the most. Number 6, this is a straight up calculation. We're not having to do any algebra here. So the temperature change is 70 degrees Celsius from 10 to 80. So we do the mass times the specific heat of copper times the temperature change. You get 81,900 joules added. Here are the rest of the answers, doing exactly the same strategy. Here are those answers. Pause the video. Notice I also wrote the temperature changes in here. Notice that E and F our heat is removed because the temperature went down from 10 to -5. Notice that's a 15 degree temperature change. Notice that's a 150 degree temperature change from 200 down to 50. Number 7 is like the one that I did as an example in class. This time you're solving for the change in temperature. So when you plug the values in, I did part A here, plug in the heat, plug in the mass and the specific heat. You multiply these two together, then you divide into, you multiply these two, and like we did in class, you divide that into the 35,000 and you get 60.8. That's an increase because the heat was added. Then I decided to do pluses and minuses down here to show the increase or decrease. Plus, minus, minus, minus. Number 8. This means that it's the amount of heat that is required to do something. What is the something? The something is you take a kilogram of this stuff, you change the temperature by 1 degree Celsius. This has been Physics from Afar.